Today, we are going to talk about the central limit theorem. First of all, the sampling distribution of sample means is a distribution constructed from all means of possible random samples of a specific size taken from a population. If we selected the samples randomly with replacement, the sample means will be different from the population mean, which is denoted by mu. These differences are caused by the sampling error. The sampling error, however, is the difference between the sample measure and the corresponding population measure due to the fact that the sample is not an accurate representation of the whole population. There are two main properties of the distribution of sample means. First of all, the mean of sample means is equal to the population mean. And second property is the standard deviation of sample means is smaller than the standard deviation of population mean. Or we can say in terms of formula that the population standard deviation divided by surd of sample size is equal to the standard deviation of the sample means. For example, suppose that the professor gave an 8-point quiz to a small class of 4 students. The results of the quiz were 2, 6, 4, and 8. Let us just assume, for the sake of this discussion, that the 4 students constitute the whole population. And so we can find that the mean of population is equal to mu equal to 2 plus 6 plus 4 plus 8 divided by 4, which is equal to 5. The standard deviation, denoted by sigma, is equal to surd of 2 minus 5 squared plus 6 minus 5 squared, and so on, divided by 4, which is equal to 2.236. The graph that we can see here is the graph of the distribution. It is also a uniform distribution. Now, if we take all the samples of size 2 from the population with replacement and the mean is recorded, the distribution will be as follows. For example, the sample 2 and 2, to find their mean, we will have to add them together, which is equal to 4, and divided by 2, since there's 2 data here, and we'll get 2 in turn. From the way that I have just teach you, you can actually compute the whole table from it. From there, a frequency distribution of sample means can be computed. The histogram is constructed using the data in the previous slide. It shows the distribution of sample means, and the graph appears approximately normal. The mean of the sample means, denoted by mu x bar, is equal to 2 times 1 plus 3 times 2 plus 4 times 3, and so on, divided by 16 is equal to 80 divided by 16, which is equal to 5. The mu x bar is 5, which is same as the population mean. Hence, we can say that mu x bar is equal to mu. The standard deviation of sample means, denoted by sigma x bar, is equal to surd of 2 minus 5 squared plus 3 minus 5 squared, and so on, divided by 16 is equal to 1.581, which in turn is equals to the population standard deviation divided by surd 2, which can be clearly seen from the formula below. The sigma x bar is equal to 2.236, which is the population standard deviation, divided by surd of 2 is equal to 1.581, which is the same value that we found for the sigma x bar just now. In conclusion, if all possible samples of size n are taken with replacement from the same population, the mean of the sample means, denoted by mu x bar, is equal to the population mean mu. The standard deviation of sample means, sigma x bar, is equal to the sigma divided by surd of n. And so the standard deviation of the sample means is also called the standard error of the mean. The formula sigma x bar equal to sigma divided by surd of n signifies that the larger the sample, the less the variability in the sample mean. That's all for today. Thanks.